Hello everyone. So our today's topic is heat energy and power produced in a resistor. Now remember, this topic is basically used in many other topics like the formula, the concept. It is used in many chapters, many units. So please learn the derivation and also how to solve the important numerical. Okay, so let's move forward. So first let's discuss how an electron moves in a wire when a battery is connected. So if we'll see, this all are atoms, they are stationary atoms. And this is an electron which is drifting from negative terminal to positive terminal. So if you'll see, the electron collides with the stationary atoms. So whenever there is collision between a fast moving body and a stationary body or any moving body, then there is heat energy which is produced. So while drifting from negative terminal to positive terminal of a battery, electron collides with stationary atoms in between. And what happens when a fast moving body collides? Let's see. So we'll see, heat energy is produced when there is a collision. So in a current carrying wire, since electrons are colliding with stationary atoms, so lot of heat energy is getting produced because there are millions of atoms which are moving when current is flowing in a wire. Okay, so you have to remember this concept. What concept? The concept is that what happens to the energy from battery? So we have an electron which starts from negative terminal of battery and it drift towards positive terminal of battery. So initially also the electron is stationary, finally also the electron is stationary. So what happens to the energy that it has taken from the battery? The energy is converted into heat. So remember this concept that whatever energy battery supplies to electron gets converted to heat energy. So whatever work done by the battery gets converted to heat energy. Now, what is the work done? See, we have already learned this formula in electrostatics. Also, you must have learned this formula in class 10th also. So suppose across this wire, the potential difference is V and the charge which is moving is Q. Then work done will be equal to potential difference into charge. You have to learn this formula. Suppose if I ask that an electron is moving in a wire, so in the place of Q, you have to put charge of one electron. Okay. Now work done is basically potential difference into charge, and we have already learned that whatever be the work done, it will get converted to heat energy. So heat energy produced will also be potential difference into charge. Now power is work done per unit time. Work done is V into Q divided by T. So we can write it to be V into Q by T. And charge flow rate is current. So power is V into I. Now we know that V is equal to IR. This is Ohm's law. So on the place of V, if I'll put IR, then power will be equal to I square R. All these formulas are very, very important. Now power is I square R already, right, and power is work done per unit time and work done is heat energy because whatever is the work that's converted to heat. So heat will be I square RT and we can also write it to be VIT. So all these two formulas are very important. Formula for heat energy is equal to I square RT. So heat energy produced in the resistor depends on current in the resistor, value of resistance, and the time for which current is flowing in the resistance. And if I'll put IR as V because it's Ohm's law, then we can also get VIT. So heat energy depends on current, resistance, and most importantly for how much time you are passing the current. So now there are two important concepts that you need to remember to solve MCQs now. Suppose we have two resistors R1 and R2 connected to a battery of potential difference V, and suppose current in the circuit is I1. So if here current is I1, then in R1 also current will be I1, in R2 also current will be I1. So what I'll do, suppose I add another resistor R3 in series with R1 R2. Now see, suppose now the current is I2. We have kept the battery potential constant. Remember that I1 will not be equal to I2. In series, if you will add resistors or if you will delete resistors, then value of current will change. So if current will change, then remember heat produced will also change. So remember, In series, if you try to do anything with the circuit, within series circuit, then value of current will change. But in parallel, now see what will happen in parallel. So when resistors are connected in parallel, suppose we have R1 and R2 connected in parallel with each other. Suppose in R1 current is I1, suppose in R2 current is I2 and potential difference is V. Suppose I add another resistance R3 in parallel with R1 R2. Now we'll see. Suppose now current in R1 is I1 dash, current in R2 is I2 dash. Then remember, when resistors are connected in parallel, the parallel branches are independent in nature. So if you are not doing anything with the R2 branch or R1 branch, then current in them will not change. And if current will not change, then heat will also not change. The reason for this is in parallel, the branches are independent. So whatever you do with R2, you add another with R2, you remove R2, current in R1 or R3 will not change. So in series, if you do anything in the circuit, in the series circuit, then current will change. But in parallel, the current will not change. This is a very important concept while solving MCQ. Now, we have learned formula for power, for heat, the concept behind power and heat, and also the concept that if you do anything in series circuit, then current and heat and power all will change. But if you do anything in parallel circuit, like suppose we have three branches, and if you do something with one branch, then another two branches are independent. So on the basis of this concept, now you have to submit an online quiz. So I'll be sending link to the quiz today. So please submit it, and if you have any doubt, you can WhatsApp me.